All right, a little practice of what we were doing before. Square root. Half means square root when it's an exponent. So it's 5. Square root and cubed. It doesn't matter, you could cube 4 first. But I always do the roots first. It keeps the number small. So my final answer is 8 for that one. Cube root, and then square. So cube root of 8. Again, with these ones where it says without a calculator, guess a small whole number. What times itself gives you 8? Oh, 2. Don't forget to actually square. 1 over 4th root of 16, again, 2. And then cube it. So final answer is 1/8. 10 to the negative 2, flip and square. So now remember, fraction numbers are not fraction exponents. 32 to the negative 2/5. 5th root squared. Okay. Guess small. Oh, 2. It's nice to know a couple of small powers of 2. That way you can do a lot more things by hand. Okay, so let's read this because this is kind of important. To solve 3 to the x is 81. Basic arithmetic facts, because 3 times 3 times 3 times 3 is 81, so x is 4. But if I wanted to solve 3 to the x equals 82, I need to be able to scrape the x out of the exponent. And we have a new definition, logarithms. You've heard about them. They're fun. Something to notice, and I want you to be thinking about it this way. The base of the log is the base of the exponent. Let me write that down here. And 2 cute things. Log without a base is base 10. And then this weird thing that looks like an IN, but it's LN, stands for log natural. It's base E. What's E? It's a number a little less than 3, the way pi is a little more than 3. It turns out to be really important for calculus and a little bit of statistics, but something you just have to sort of get used to. Okay. Writing each equation into exponential form, again, the base of the log becomes the base of the exponent. 3 to the, go across the equal sign, is 81. What's the base? 10. Base ln is E. What's E? It's a number a little less than 3 for our purposes. But notice that ln gets treated just like any other base. 3 to the, go across the equal sign. Right, there we go. If I only knew how to type log base 3 of 82 into my calculator, which we will learn soon, I would be able to solve the question I pointed out in all that words. I could figure out what number slightly more than 4 gives me 82 when I use it for an exponent. Okay, back to log form. Again, the base of the exponent is the base of the log. Make sure the base goes way low, go across the equal sign. It should not look like 3 to the 5th. Okay, so be careful that I don't want to see 243 floating up in the air, for instance. So log base 2 of 128 going across the equal sign, then back. Yes, I will penalize you on the quiz if you put a 10. And don't write log base E instead of ln. Okay, so 10 log of 350 is x. Oh, so if I wanted to know what power of 10 gives me 350, I actually have a button for that on the calculator. Log of 350, I can just type it in. So notice logs tell you what the exponent is. That's really important for the last bit, because I'm thinking about what is the exponent that turns 4 into 16? Oh, that would be 2. Log base 4 of 16 is just the number 2. Just like square root of 25 is just the number 5. What power of 10 gives you 100?
It's a question mark exponent.
2. What exponent gives you square roots? One half. Oh. 1 over 49, that would be flip and square. Oh, that was terrible. Okay. Log of 1, again, the base is 10. What power gives you 1? Oh, that would be 0. Log base 4 of 8 is tricky until you realize you can go through 2. So the combined exponent is, let's see, what is the exponent for square root of 4 cubed? That would be 3 halves. Okay, speaking of which, if I just want to turn 8 into 2, I just need 1/3 for an exponent, cube root. So notice that log base 2 of 8 and log base 8 of 2 are reciprocals. Log base 3 of square root of 27, I need a half for the square root. And how do you turn 3 into 27? You cube it.